Okay, so our first one, Mario already has his hand up. Mario, how do we do that?
First off, I simplify it, so 4 would be 1 and 24 would be 6.
What? 6 would be 1 and 24 would be?
Oh, yeah, that
would be 4?
Yeah.
Okay. So, was to see that you could see that 6 and 24 had a common factor. The common factor is 6. 6 goes into 6 one time. 6 goes into 24 4 times. You did not have to do this first, but it saves you from large multiplication and division. So now we're going to cross multiply. So Mario, when you cross multiplied, what did you get? X equals 4 times 4? 16. You could have also done it without... Ooh, I didn't mean to take rid of it. Give me 1 second.
That's what I had to do.
You could also... Come on, Jenkins. Have done it that way. Yep. So you'd have 6x equals... What's 4 times 24? So then you'd have 6x equals 96. Divide by 6. X equals 16. So those were your two options. If we're going to do that, that's fine as well. Over here we have number 2. Who would like to try number 2? Nico, would you like to try this one? You had your hand up for the last one. Okay, so you.
4z.
So we end up with 4z equals. $198. We're going to divide by 4 because we're isolating our z. We get z equals. Would somebody like to help her? 49.5. Nice job. Okay, over here we have our next group. Again, it's cross multiplication. You could either do what Mario did previously and reduce, or we can just multiply them out. So this time I'm just going to multiply them out. We see we end up with 10 times the quantity of x plus 1. This is the number one error, is you guys not putting parentheses. So 10 times x plus 1 equals 6 times 4. I'm now going to distribute. So that means I'm just going to spread that to both of them. I end up with 10x plus 10 equals 24. I have to get my like terms together. My like terms in this case are my constant terms, which means I'm going to subtract 10 from both sides. Jaheem, do you have a question? Okay. And then we are going to isolate to get our x by itself, which means we're going to divide by 10. So I get x equals what? 1.4. Nice job. And then our last one on this slide, we see again we are cross multiplying. So here we have 1 times y. 1 times y is just y, which equals 5 times my quantity of 3 minus y. I get y equals, I've got to spread that love, distribute it, which gives me 15 minus 5y. I have to combine my like terms. My like terms in this case are things that have variables. So I'm going to add 5y to both sides. Exactly right. I get 6y equals 15. I've got to get my y by itself. I'm going to move this right over here so we have space, which gives me y equals 15 over 6. I can reduce that to be 5 over 2. 3 goes into 15 5 times. 3 goes into 6 2 times. So I get 5 over 2, and I believe someone just told me that answer, y equals 2.5. So if I didn't have a calculator, if not, I would just put it in. Okay, so we see we have 7.5 proportions in similar triangles. We have our objective, which you're going to write on the top of your page. Use the triangle proportionality theorem and its converse. That goes on the top of your page. Card here is our definition. Our definition is divided proportionality when ratios of two segments with corresponding lengths are equal. So divided proportionality is when ratio of two segments with corresponding lengths are equal. Okay. We're going to do our first example. This is the definition, or not the definition, this is the directions, but it's actually on the next slide too. So we really don't need it there. We have our first example. So we want to find the ratio of BC to our AB to BC. So you cannot see it because I didn't click it far enough. So if you were going to do this, what is the ratio of AB to BC? What's the distance?
5.
What is the distance of AB?
2.
So we have 2, 2. We use our colon. What's our distance of BC?
3.
3. So 2 to 3. We also have DE to EF. So we are going to create this ratio looking at our distance. So what is DE?
4,
To what?
6.
4 to 6. So to what is our proportion of these segments? Well, we're going to look at 2 over 3. We want to see if it equals 4 over 6. How can I reduce 4 over 6? Divide by 2. We end up with 2 over 3. So right now we have the so what did you say, Nicola? We see they're equal, which means that we're going to have that proportion of 2/3. Is the triangle proportionality theorem. So if a line parallel to two sides of the triangle intersect the other two sides, then it divides the two sides proportionally. So you see here that these little weird marks are supposed to be those arrows to tell you that they're parallel. That's what's supposed to be happening here. I'm going to highlight the equation there. So we see, Nicola, yes? So ideally you are writing them down. If you need some note cards to write them down, I can give you the blank note cards. So we see we have RT, which is this length. And we have TQ, which is the segment that makes that the larger triangle, which is going to go on the bottom. So up until this point, we did the small side over the whole length of the large side. And now we're doing the small side with the little portion that makes it the long side. And then over here, we have RU, our small side of our triangle, over US, the segment added to it to make it the long side. So that's what this one is telling you. So if they are parallel, then we see that these proportions are going to equal each other. These ratios are going to create equal proportions. Again, you're just adding those letters. It's the same that we've dealt with in the top, and the other part is the same theorem we just got. Okay, so we have this one. So we're going to create these ratios. We see that we have our small triangle has a side of SC, and then the segment that's added to it to make it the large triangle is CR. And we want to make sure it's equal to our smaller triangle side, SD, over, what'd you say? DT, exactly right. Now we're going to substitute in what we know. So SC is what value? Over equals SD, which is over 10. So what's going to create these to be equal? So I'm now going to either A, reduce, which is what we did with Mario, and that might make it a little easier, or we can go on through. Would you rather reduce or just multiply out? We're going to divide by 10 first. Okay? So if we're going to reduce, 10 goes into 20 how many times? 10 goes into 10 once. Okay, now I'm going to cross multiply. I end up with 22 times 1 equals 2x. We're going to divide by 2. 22 divided by 2 is 11. We see here that we have to create those ratios again. Now we're looking for y. This does not have letters, so I'm not going to make you write the letters. But we see the small side of this triangle is 10. What we add to it to make it the larger side of the triangle is 14. Equals the small side of my triangle here is y. And then we want to know what this length is. So if we know the whole thing is 36, we know this part here is y. How can I represent this part down here? So we could potentially do x, but there's another way to relate it using these two numbers. We don't have to necessarily divide. So if the whole thing's 36 and we took away y, we're left with just 36 minus y. So whatever is not that y is going to have to be what's down here. So we see we have over 36 minus y. Once again, I'm at that same spot. I'm cross multiplying and simplifying. I see that I have 10 times 36 minus y equals 14y. When you see those parentheses, even if they weren't originally on our denominator, we still have to put them there. I now have to distribute. Bam, bam. I see I have 360 minus 10y equals 14y. Yep, we got to combine like terms, which means I'm adding 10y. I get 360 equals 24y. Divide by 24. y equals,
15.
what is it, hon?
15.
15. That these would be parallel if those two ratios are equal. So we want to see if that's going to be the case. So I see that I'm going to create the ratio of AX over XB. We want to see if it's equal to AY over what? YC. Nice job. We're going to substitute in what we know. We know AX is what amount? Over? Which equals? Over? Okay. We can reduce our left-hand side. What goes into 56 and 48?
8.
So how many does 8 go into 56?
5. 6
So we see it goes into it 7. How many times does 8 go into 48? 6. Okay. Can I reduce 21 over 16? What goes into both of those? We see we cannot reduce them. So is 7 over 6 equal to 21 over 16?
No.
They're not equal, so these are not parallel. Not parallel.
So can we just write no instead of writing that one? You got this one.
So for this one, previously all of our examples had to deal with the fact that we had this length and we added this length onto it and created that ratio, right? This one we're going to do back to the way we did it before, where we do our smaller side of our triangle over our larger side of our triangle. So what do these little tick marks tell us? They're congruent, which we know congruent means? Same measure. Yep, so I know that I'm going to create the ratio using AX over AB. So smaller side over larger side. And I have AY. So this one's the whole larger side. So AC. And it equals, we see again we have Y, or XY over BC. Okay, so we don't have any numbers other than the 16. But we do know the length that AX is going to be the same length as XB. So because we know that's the same thing as 2AX. So the length of the whole side is 2 times AX. So if I keep this in terms of AX, I see I have AX over 2 times AX. So the whole side length is double that first part. When I go to the second one, I see that if we keep it in terms of AY, we still have that congruent mark. So I end up with AY over 2 times AY. So it's twice the length of the smaller side. And then our last one, we see we actually have information here. We have X and 16. So I'm going to put X in my numerator and 16 in my denominator. When you have the same thing in the numerator and the denominator, you can cancel it. So we see we have AX in both the numerator and the denominator. We have AX in the numerator and the denominator. We have AY in the numerator and the denominator. So here I have 1/2 equals 1/2 equals X over 16. We only need one of those 1/2. That's just telling us that we have the same ratio. So now I can take the 1/2 and then cross multiply. So we see we have 1 times 16 equals 2 times X. We divide by 2. 16 divided by 2 is X equals 8. Okay, so this one was different because now we're taking the whole side length and the smaller side length again, just like we did previously.